All right, good evening, good afternoon, good morning. Welcome to this remedial class. So this is a Science 2017 paper 1, I presume. Okay, so the question that we are going to build on today is this question here, A17. Okay, and this build on from static electricity. That is what we were looking at, static electricity, which is basically just about electrons that are stationary. Okay, and that is the definition of static electricity, electrons that are stationary. And now we're going to look at current with the symbol I. So wherever you see the symbol I, that is current, and it is measured in amps. So this is basically when electrons are moving, okay, and measured in amps. Okay, static electricity measured in coulombs. Okay, that is charge. Okay, now here we are going to start with this question here, and it will just help us understand how current behaves when it is in a circuit. So the question reads, the diagram below shows a circuit with 4 ammeters. So ammeters, these are basically devices that measure current. Devices that measure current. So devices that measure current. Connect different positions. So these are the different positions. And 3 resistors with different values. Which of the 4 labeled A, B, C, or D ammeters will show the largest reading? Okay, so that is the question. Which one of these, A, B, C, or D, will show the largest reading? Now, first of all, you need to know how current moves when it is in a circuit. And how you know how it moves is by identifying the cell that you have. So for any cell, there will be a long side here and a short side. The long side is the positive and the short side is the what? The negative. And current always moves from the positive part going towards the negative. Okay, so it will move always from the positive part going towards the negative. And when it reaches a point where wires are splitting, it also splits into those wires. So there will be some different current going through this wire here. So again, it reaches there, it will stop. Then there will be some different current going through this wire here. Again, it reaches a point where it is splitting, so it also needs to split into 2. So some of it will go through in that wire there, and some of it will go down that wire like that. Okay, so go down that wire like that. So, and just as it split, when the 2 currents meet, they rejoin and form the current they previously split into. So like in this case, these 2 currents that are rejoining were split from the blue current. So when they rejoin here, they form the blue current again, which is the current. Same applies here. The green one and the blue one, which is this current here, split. So when they meet, they will make the current they split into, so which is the red current there. So they will remake the red current there until it gets to the other part of the battery there. Okay, so now we have current 1 here, which is the current we are starting with. So the current we are starting with is the current with the biggest amount of amps, or the amount of value. Then when it splits, it shares its current. So it reduces. So this one here reduces. So we'll call this current 2. And down there, it reduces as well. We call this current 3. Okay. And this current, again, when it reaches another point where it is splitting, the current here will be smaller. Okay, so that is current 4, and then there will be another current going down there, current 5. Okay, so in simple terms, current that splits, okay, like the current in red here. So current 1, when it splits, it is equal to the current in green, which is current 2, plus the current in blue here, because it splits into that, so the current in blue. Okay, so this is why, again, when the current in green, which is this current in green, rejoins with the current in blue, they will make the current in red. Okay, so this is one of Kirchhoff's laws, but we'll not delve into that. So, but what you should just understand is that when current enters a particular junction or point where wires are splitting, it also splits, and the values that it splits into are lesser than the original one. So, but here, so now having that explained, which one do you think would have the largest reading? So the largest reading will actually be given by D here, because D here has the current of the original current here, the current that it started with. So D will have the original, will have the largest reading because it is the current that it started with. Then from there, the second largest to say will be these two, because these are from the original current. Then the smallest reading would be this one, because this one is from the splitting of this one, which is from the splitting of this one. So this one is smaller here. Okay, so the answer here is D. Okay, now having that said, we can also look at the type of connections that can be made on a circuit. So you can just write this for your own memory. You can just write that. Then let me talk about the type of circuits or the type of connections for resistors. Okay, so the first one that we can talk about is this one, where resistors are in parallel. So parallel simply means they have junctions. So resistors have junctions. So like here, this resistor here is in a junction with this resistor here, is in a junction with this resistor here. So they are not in the straight line. So whenever there is a junction between the resistors, we say that those resistors are in parallel. Okay, so wherever there is a junction there, we say they are in parallel, or when they are in straight line like this. So sometimes it could just be like this. So this is a resistor there, another one there, so another one there. Okay, so these two resistors are in parallel because there is a junction between them. So there are junctions between them. So these resistors are in parallel. The counter to this one is for resistors that are in series. So resistors in series, there is no junction between them. So if this is a resistor there, another resistor could be there. So there is no junction between them. Then we say that the resistors are in parallel. So, and here like that, so to the battery. So these are in series because there is no junction. Okay, and when current comes, it just comes directly through these. Okay, so the current going through each of these is the same. So the current in this one, in this resistor here, is the same as the current in this resistor, and it is the same as the current in this resistor. But for resistors that are in parallel, the current here has a different current, the current there has a different current, and the current there has a different current, okay, which we can call current 3 there. Okay, and you will be required to find these currents. Now for resistors, first of all, before we even go to current, how do you find the total resistance? Okay, the total resistance for resistors in series. So this is, if this is resistor 1, this is resistor 2, and this is resistor 3. The total resistance, which we're calling R total, will be equal to just summing these resistors. So it will just be resistor 1 plus resistor 2 plus resistor 3. So this is for in series. So we're just summing the resistance, because the current will, or let me say the voltage will face a different resistance here, it will face a different resistance here, and it will face a different resistance there. So the total resistance will just be adding these resistance for a series. Okay, for parallel, the resistance total is calculated using the formula 1 over resistance total is equal to 1 over the resistor 1. So if this is resistor 1, this is resistor 2, and that is resistor 3. So it would be 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. So this is the formula for parallel. I think it's like that. So this is the formula for parallel, and this is for series. Okay, so now we can even calculate the total resistance from this equation here. So let's look at this question here, and we calculate the resistance here. So here we can observe that these resistors have junctions between them. So these are in parallel with each other. Okay, so now the total resistance is, let's say this is resistor 1, this is resistor 2, and that is resistor 3. Just use the formula 1 over resistance total will be equal to 1 over resistor 1, which is 10, plus 1 over resistor 2, which is 20, plus 1 over resistor 3, which is 30. So 1 over resistance total will be equal to finding the common denominator here, which is 60. Then we'll say this will give us 6 plus this into there, it will give us 2 plus 3. Oh, will it? So this 20 into there, that will give us 3, and 30 into there, that will give us plus 2. And we'll say 1 over resistance total would be equal to 11 over 60. Then from here we can cross multiply. So when we cross multiply here, we're going to have 11 resistance total will be equal to 60. So 60 times 1, it will be 60, 11 times that. So now from here we can divide by 11, divide by 11. So this cancels, and the total resistance in equal to about 0, is it 5 point, that would be 5.45 approximately, and resistance is measured in ohms, so we put ohms. So that is the total resistance in this case. And now, in addition to finding the total resistance for a given circuit, you can find the current going through each of these resistors. Okay, so now remember here there was a different current going through there, and there was a different current going through there, there's a different current going through there. You can find all these currents. Now what you need to note is that let's say you've been given the voltage here. So suppose you've been given, let's say, 7 volts. So for instance, if this is a 7 volts battery, what you should know is this: the voltage only reduces after it goes through a resistance. Okay, so that is when the voltage reduces. So in this case, when the voltage comes here, the voltage going through this resistor will be the same as the voltage going through that resistor, and it will be the same as the voltage going through that resistor. So here 7 volts is going there, 7 volts is going there, and 7 volts is going there. So for parallel, voltage across resistor is the same. Okay, that is for parallel. But for series, so for instance, if we have resistance like that in series, okay, so these resistors are in series, for instance. So this is resistor 1, resistor 2, and resistor 3. Okay, Now, when voltage goes through the first one, it decreases. Okay, so voltage here decreases. When it goes through another resistor, it decreases, becomes less. When it goes through another one, it decreases. Okay, it becomes lesser. Okay, so this is what we'll look at later, but for now what we just need to know is that voltage across this resistor is the same as voltage across that resistor is the same as the voltage across that resistor, and we can use Ohm's law to find the voltage. Ohm's law simply says the current is directly proportional to the voltage and inversely proportional to the resistance. Okay, so for us to find the current through each of these resistor, we'll just say the current one will be equals to the voltage across this resistor, which is 7 volts, over the resistance, which is 10. Okay, 10, and this would give us 0.7 amps. So that would be the voltage, the current through this resistor. Then current 2, the current through this resistor here would be equal to the voltage, which is this voltage, 7, over the resistance. The resistance, we just write like that. So the voltage is 7 again, then the resistance there is 20. So that would be 7 divided by 20, which will give us 0.35. So the current through this is 0.35, 0.35 ohms. Okay, then we can also find the current through that. So current through that, which is current 3, is equal to the voltage, which is 7 volts, divided by 30. Okay, and this would give us 7 divided by 30, that would be 0.23 amps. So we found the different currents through this. We can also find the current that will be shown on this D here. So the current that will be shown on this D, since we have this current here and this current here and this current, they re-emerge to form the total current. So total current will just be current 1 plus current 2 plus current 3. Okay, which will just be adding each of these currents, and that will be the current that will be shown on D here. Okay, so basically what we've talked about is resistance. So we know how to find resistance for parallel. We know how to find the resistance for series, and we can find current for each resistor when the resistance are in parallel, like we have done. So for resistors that are in parallel, it's very easy to find the current through each of these resistors. And that sums up what I just wanted us to look at. I'll put some questions. I'll just put one question here that you can try out. Then we'll see how we'll move on from there. All right, so for this question, C here shows the resistors connected in parallel. Simple task, I just want you to find the current that will go through this resistor and the current that will go through that resistor. Secondly, I want you to find the voltage that will go through each of these resistors. Okay, so the current in that resistor, the current in that resistor, then you find the voltage in each of these resistors.